Hey y'all, so since finding the inverse of a 3 by 3 is so strenuous, I wanted to go ahead and record this video so you can play it back if you need to. So we have a 3 by 3 matrix and it's wanting us to find the inverse of A. So whenever we're finding the inverse of A, the first thing that we need to do is find the determinant of A. So in order to find the determinant, we're going to go ahead and rewrite the first column next to the matrix, 0, 1, and 4, and the second column next to that. Then we're going to find the product of our diagonals. So again, we're finding the determinant here. We're going to find the product, so multiply 0, 0 times 8 is 0. 1 times 3 times 4, which is 12. And then 2 times 1 times 3, which is negative 6. Then we're going to find their sum. So we're finding the sum of the products. So we're going to be left with 6 here. Then we're going to do the same process, but this time for the diagonals going the opposite direction. So we have 4 times 0 times 2, which is 0. Negative 3 times 0, which is 0. And then 8 times 1, which is 8. Then we're going to find their sum, which is going to give me 8. Last but not least, I'm going to take their sums and I'm going to subtract them. So the first diagonals minus the second diagonal, 6 minus 8, which is going to give me negative 2. So my determinant of the matrix A is negative 2. Remember, you can write it as such, or you can write det A is negative 2, whichever one tickles your happiness. Now, keep in mind that whenever your determinant is 0, you cannot find the inverse. So what we're going to do is we're going to take our determinant here, and we're going to go ahead and put it in the inverse formula. So we're finding the inverse of A. Make sure it's an inverse notation. And we're going to put the determinant under 1. So we have 1 over negative 2. Keep in mind that we can't divide by 0. It would give us undefined, which is why whenever your determinant is 0, it's impossible to find the inverse because that fraction would be undefined. So now I'm going to go ahead and find a bunch more determinants. So I'm going to go ahead and erase this so we can see it better. What I'm going to do is I'm going to take each corresponding piece. So if I want this piece right here, this upper left-hand side, I'm going to look over here, the original matrix, at the upper left-hand side. So see this 0 that's in the spot that we're looking for? I'm going to take that. See this red piece? I'm going to take that and cover up the column that that number is in. And then I'm going to take this and cover up the row that that number is in. So I'll say it one more again. What's happening is I'm looking for this top left piece right here. So what I'm doing is I'm covering up the row that the upper left-hand piece is in and the column. So I'm covering up both corresponding pieces. You see everything that's left? We're going to find the determinant of that 2 by 2. So we have the piece that's left, we have 0, 3, negative 3, and 8. Now we're going to do the same thing, but with the next piece. So now I want to find this middle piece right here. So I'm looking at the corresponding piece here. So see how we have a 1 in that spot? I'm going to cover up the row and I'm going to cover up the column. Everything that's left is what I'm finding the determinant of. So I have 1, 3, 4, 8. Then I'm going to do the same thing with the next piece. So I'm looking for the top right-hand side. So over here at the original top right-hand side. So I have a 2 in that place. I'm going to cover up the row, cover up the column. And every piece that I'm left with, that's what I'm finding the determinant of. So I have 1, 0, 4, negative 3. All right, now I'm going to do the same thing with the rest of the pieces of the matrix. So I'm looking for my next piece. So I'm covering up the row, of the corresponding part and the column of the corresponding part. Everything that's left is what I'm finding the determinant of. So I have 1 and 2, -3, 8. Next piece, I'm looking for the spot that the 0 is in right here. So I'm covering up the row, covering up the column. Everything that's left is what I'm finding the determinant of. 0, 2, 4, 8. Last one on the right, I'm finding the piece that this 3 is in right here. So I covered up the row, covered up the column. Everything that's left is 0, 1, 4, -3. Last row, I'm looking for the spot that the 4 is in. So I'm going to cover up that 4, cover up that column. Everything that's left is 1, 2, 0, 3. Then same thing on this side. I'm looking for the spot that the -3 is in, so I'm covering up everything else. 0, 2, 1, 3. Last but not least, the last column. I'm looking for the spot that the 8 is in, so I'm covering up everything else. What's left is 0, 1, 1, 0. Okay, now that I have a really big matrix, now what I need to do is I'm going to find the determinant of all of those pieces. So we're going to have the inverse of A equals, we still have that 1 over -2. I'm going to keep that. I can't get rid of it. And then I'm going to work piece by piece to see what I'm missing. So here in this determinant, we have the column, or sorry, the diagonal here, 0 times 8, which is 0, minus this diagonal, -3 times 3, which is -9. Then we're going to have the same thing on this side. We're finding this determinant. So we're going to have 1 times 8, which is 8, minus 4 times 3, which is 12. Last but not least, we're going to have this determinant, 4 times 0, which is 0, 1 times -3, which is -3. We're going to do the same thing with the next row. We have 3 times -2, which is -6, minus 1 times 8, which is 8, 0 times 8, which is 0, minus 4 times 2, which is 8, 0 times -3, which is 0, 4 times 1, which is 4, 1 times 3, which is 3, 2 times 0, which is 0, 0 times 3, which is 0, 1 times 2, which is 2, 0 times 0, which is 0, and 1 times 1, which is 1. Okay, now that we have all of these pieces, I need to go ahead and find my pattern of opposites. So what I mean by that is, remember when we were finding the adjoint of A yesterday? So the adjoint of A, what we were doing was we were taking the matrix A, B, C, D, and we were finding the adjoint, which means that we're going to switch the A and the D, and we're going to turn the signs of B and C opposite. So the original A would have been A, B, C, D, and the adjoint of that would be D, -B, -C, A. So again, what we did was we switched the A and the D, and then we changed the B and the C into opposites. So what we're doing here, since it's a 3 by 3, obviously it's going to work differently. However, we still have this pattern of opposites. So notice how D is still positive. It's still going to start positive. So this parenthesis right here is still going to be positive, or this determinant is still going to be positive. The next one, negative, positive, negative, positive, negative, positive, negative, positive. So you should have a pattern. I like to think about it as diagonals, or like a diamond shape. So we're going to have a diamond shape of negatives. Okay, now I'm going to go ahead and simplify it. So this piece right here, we have 0 minus -9, which is going to give me 9. Then we have 8 minus 12, which is going to give me negative 4, but multiplied by negative, which is going to give me positive 4. Then we have 0 minus negative 3, which is 3. Negative 6 minus 8, which is going to be negative 14, but multiply it by a negative, which is going to give me positive 14. 0 minus 8, which is negative 8. 0 minus 4, which is negative 4, but multiply that by the negative outside, which is going to be positive 4. 3 minus 0, which is 3. 0 minus 2, which is negative 2, but multiply that by the positive outside, which would give me positive 2. And 0 minus 1 is negative 1. So we are left with a much nicer matrix. Don't worry, we're still not done yet, but we're left with a much nicer matrix. Okay, now looking at the adjoint of A again, we already dealt with the opposite signs here, but we haven't dealt with how A and D switched, right? So what we're going to do is we're going to have to switch A and D again, but of course, ours is in a 3x3, so it's going to look different. All right, I'm going to go ahead and do that part up here since we ran out of room. And let's go ahead and clean it up again so it's easier to see. 4, 14, and 8, 4, and 3, 2, negative 1. Beautiful. All right. So this is what I was left with down there. I just rewrote it because I ran out of room. Don't worry, I didn't sneak anything in there. Now, this diagonal right here, this is going to stay. So I'm going to leave that diagonal there. So it's going to look like this. The first spot is still 9. The middle spot is still negative 8. This spot over here is still negative 1. Now, everything else reflects over that line. So it's kind of like if you had, it looks like a line, obviously. So if you had like reflecting over y equals negative x, it's kind of the same thing. So we're taking all of our terms and we're reflecting it across that line. So if we see here, this 4, if we reflected it over that line, see how it lines up with this 14? Those are the ones that are going to switch. So kind of like catty corner A and D switch in the adjoint, it's kind of the same thing. The 4 and the 14 are now going to switch. So this spot is now going to be 14, and this spot is now going to be 4. We're going to do the same thing with the other numbers. So see how this spot right here is 3. If you reflect it across this blue line right here, it would line up with this spot, which is also 3. Sorry, this one was negative 3. So this spot should be negative 3, and this spot should be 3. Finally, the same thing, this 4 right here, if you reflected it across that line, it would line up with that 2. Those are the pieces that are trading spots. Nice. Okay, last step. We have this piece left. Now we have scalar multiplication, so kind of like distribution, but we're talking about a matrix here. We have scalar multiplication with this negative 1/2 outside. So of course we didn't forget about her. We're going to have to multiply everybody on the inside by that negative 1/2. So my inverse of A, final answer, I promise, is everything inside of it multiplied by that negative 1/2. So I have 9 times negative 1/2. I'm leaving it a fraction because fractions are people too. We're going to have negative 9/2. 14 times negative 1/2 is negative 7. 3 times negative 1/2 is negative 3/2. 4 times negative 1/2 is negative 2. Negative 8 times negative 1/2 is 4. 2 times negative 1/2 is negative 1. Negative 3 times negative 1/2 is 3/2. 4 times negative 1/2 is negative 2. And -1 times -1/2 is just 1/2. All right. So this is our final answer. The only thing that I would make sure that you're doing is double checking to see if anything can be simplified. In our case, nothing can be simplified. So our final answer is inverse of A equals this cute little matrix right here. So if you have any questions, as always, you can email me in Schoology or online. Also, keep in mind that just like solving regular systems of equations, there are countless ways to do this. So if you're in class and you have like a different way, for example, in second period, we did it a completely different way than we did in other classes. Use whatever works for you. Okay, so at the end of the day, you're still going to get the same answer. If one way that you did it works out and gives you the same answer, then it's fine. It's fine. We love math. Okay. Let me know if you need any help. I'm here. Have fun. Good luck, and you know the rest. Okay, bye.